Okay, today we're going to do topic 5.1, solving equations by factoring. First topic in Unit 5. And last unit we learned to factor equations and completely, factoring out the greatest common factor and then getting one or two factors, linear factors, for a quadratic, which means the quadratic, remember, a quadratic. Let me get my pen. Come in here. Hopefully, yeah, there. Quadratic means you have an x squared in your equation. Linear, which would graph as a line, means you have just x's. So if you can see down here, we have two linear factors. This is a quadratic that we're going to separate into two linear factors. When they multiply these out, we would have quadratics because our highest power of x would be x squared. So anyway, that's factoring. We went from here to this, what looked like this. Now we're going to solve. We're going to get an actual value for x that solves this quadratic equation. Now the principle we use is the principle that when you multiply anything by zero, your answer is 0. So what would go in here for this question mark? 8 times something equals 0. It would be 0. Or something times a, no matter what the number is. Whatever it is, something times a, in order to get 0, this number would have to be 0. So our conclusion that we're going to write, if a times b equals 0, what has to be true of a or b? One of them or it could be both, I guess, but at least one of them is equal to 0. Okay, at least one of them is equal to 0. So when we look at two factors, we're going to say here that the x, put that in parentheses, that's your a, and the x plus 2 is your b. So if either a or b equals 0, then I can get this answer of 0. So what that means for me is that I take each factor, x equals 0 and x minus 2 equals 0, and solve them to figure out what value of x would make that particular factor equal 0. Well, this one's already there. On this one, when I add 2 across, I get x equals 2. And we can try these, we can check them. I'm not going to check every problem, but in other words, if x was 0, I'd have 0 times 0 minus 2, which is 0 times negative 2, and that gives me the answer I need for this to be a true statement, which is 0. So we know the 0 is a valid answer. What about if x is 2? We have 2 for x, and then times 2 minus 2. And does that give me a true statement? Well, 2 minus 2 is 0, so 2 times 0 is 0. So both these answers check. So those are my answers to this quadratic equation. And these will have two answers. All right, here, again, if x minus 3 is a, and x plus 4 is b, well, then if a equals 0, that means that x minus 3 equals 0. And so to solve that, we have x equals 3. If b is equal to 0, that means that my x plus 4 is equal to 0. And when I subtract 4 both sides, x equals negative 4. And so my two answers are 3 and negative 4. And again, you can put those in. 3 minus 3 would give me the 0. So that's why if that's 0, doesn't matter what this is, it's going to be 0. And the negative 4 plus 4 makes this factor 0. So those would work in that to solve that quadratic equation. Okay, now we have a little more complicated factors, but it's still, anytime you get factors, you can think of them as factor A and factor B. One of them has to equal 0 for this to be a true statement. So 2n minus 4 equals 0, and then 3n plus 5 equals 0. So add 4 across, you have 2n equals 4, and n equals 4 over 2, or 2. Okay, here you have 3n equals negative 5. Dividing by 3, n is equal to negative 5 thirds. Okay, so those would be our two answers. Now, we have a couple things that are different on our example 4. 1, 0 is on the left. It does not matter. It's still, everything is equal to 0. The other thing that's different is it's not factored already. So we have to figure out how to factor it. We have to go back to unit 4 and remember how to do that. So we have negative 28 times 2. So that I need to know, which is 56, negative 56x squared. I need factors that multiply to be that and add to be negative x. Okay, so we're going to say that 8 times 7 is 56. Since it's negative, one of these has to be negative. And since it's a negative x, we need that our negative 8 is the one that has to be negative. So we have negative 8x. We have 7x. Now we're going to use the box, or you can factor by grouping. I'll do some of each. So we have 2x squared goes here. Negative 28 goes in the bottom right. And our two factors that we figured can be in either of these other two boxes. Two factors as 2x times x. 2x times negative 4 gives me a negative 8x, and x times 7 gives me 7x. And then our last check, 7 times negative 4 is negative 28. So we've got our two factors now. They are x minus 4 times 2x plus 7. Okay. And so, again, this is A, this is B, so that means we set each factor equals 0 and solve for x. So this would be easy. This is add 4 across, we have x equals 4. Add 7 across, you have 2x equals negative 7, and then you divide by 2 to get negative 7 halves. And those would be our two answers. Okay. So, hopefully you've gotten this so far. Let's move on and do our last few examples. Got 3 more examples here. All right, what's different in these two is we don't have everything equal to 0. We have to make everything equal 0. So we have to shift some of our elements of the quadratic to one side or the other. Now, this is my advice to you here. Make the squared term positive. Okay. So look where your squared term is. Here it is. And it is positive. So that means what I'm going to do is I'm going to take these and move them over here. So I'm going to subtract 24 and add 5a. Then write them in descending powers of the variable. So I'm going to write a squared. I'm going to write the 5a next. And then the constant 24 last. And that's going to equal 0 because all of these add to be 0. Now we need to factor. Since there's not a coefficient, we should be able to factor mentally. So a times a is a squared. And we have a plus and a minus factor because of this second minus sign. 8 times 3, 8 plus and minus 3 will multiply to be 24 and add to be positive 5. So setting each factor equal to 0, a would be negative 8, and the other a would be positive 3. I didn't show the work that I set them equal to 0, but you can always think just it's the opposite sign. When there's no coefficient in front of a, the value that would make that factor 0 is the whatever the opposite sign of the one that's there. So instead of 8, it would be negative 8 in this first factor. Instead of negative 3, it would be positive 3 in the second factor. All right, looking at example 6, here our 3x squared, our squared term is negative. So that's the one I'm going to shift because then it will become positive. I'm going to add 3x squared to both sides and I end up with 0 over here. I have 3x squared. Now again, I want descending powers of x, so the next thing I'm going to write is minus 19x and then plus 6. Now we've got a factor. We need factors that will add to be 18x, or multiply, excuse me, to be 18x squared and add to be negative 19x. Well, that's going to be, they're both negative, so it's going to be negative 18 and negative x. So, if we have our box, you have 3x squared, you have negative 18x and x, and your 6 goes there. Okay, 3 is 3 times 1. It's the only way we can get a 3. 3 times negative 6 would give me negative 18. X times 1 gives me x, and negative 6 times negative 1 is, that should be negative x, and so that is a negative 1. And then negative 18x times negative 1 is 6. Now, see, that was an advantage of going ahead and double checking that last number because I would have had that sign wrong. I miswrote this x as a positive x at first, but I realized that I needed a positive 6 and I had a positive 1 there. So always be sure you do that last check on that last number. So our two factors are x minus 6 times 3x minus 1 equals 0. Set them both equal to 0. I'll go ahead and show it this time. Okay, so the value of x here will be 6. This will become 3x equals positive 1, so x equals 1/3. And then you need to look back at the factors and make sure that those will make at least one of the factors equal 0. So now we go down to an application problem, a word problem. We've got area of a rectangular room. So you've got a rectangle. And the area is w squared minus 7w equals 18. And we know the width and the length. Well, if I factor this, the answer will be w equals something. And they want the width of the room. And that's what they asked me to find. So I'm finding w, so I should just have to factor this. Okay, so we have w squared minus 7w equals 18. Again, I need everything equals 0, so I'll rewrite that. W squared minus 7w minus 18 equals 0. Then I'm going to factor it, solving it just like we did all these other problems. It's just stated as a word problem. We have a plus factor and a minus factor. And factors that add to, or multiply to be negative 18, add to be negative 7, will be 2 times negative 9. And so when I solve this, w will be negative 2 or 9. Now in these type of word problems you have to watch because sometimes you have an extraneous factor, a factor that can't be. And we can't measure a room and get a negative number. So this one we won't write as an answer because that's an extra solution. It is a solution to the quadratic, but it's not a valid solution for this particular application problem. So my answer is just the W equals 9 because when I measure, I'm going to have a positive number. Okay? That's the end of lesson 1.